Okay, so it's 10:31. Good morning, or good afternoon, or good evening, wherever you're calling in from. We very much appreciate you joining our second ever Groundhog webinar. If you missed the first one, that was a couple of weeks ago. That was just an intro to Groundhog. This might be a good point to say we're putting all of these recorded webinars on YouTube. So if you missed the last one or you want to watch it again for some reason, you'll find it on our YouTube channel. The easiest way to do that is just to Google YouTube Groundhog Geological Software and you should find it. Please like and subscribe, obviously, all the usual stuff. So yes, welcome to today's webinar. It's going to be a little bit different today. We're doing something a bit more specific. So we're going to be looking at the 3D geological modeling tools that are available within Groundhog. We'll explain which version those tools are embedded within and how that all works. And it's going to take the form of just a live demo, basically. Not sure how long it will take, maybe sort of 30 to 40 minutes, and we'll have a bit of time for Q&A afterwards. Obviously, the usual caveats apply. Live demo, things may go wrong. We'll see how we go. And I will say a little bit about where we're at with the 3D modeling tools for Groundhog in a few minutes. But first, I'd just like to take the opportunity for the team to just say a couple of words about themselves. So we're a small software development team coming out of the British Geological Survey. We're a mixture of software developers. I'm a software developer myself. My name's Benjamin Wood. I've been at BGS for about 20 years now. I am a kind of geologist slash computer programmer. Did a geology undergrad degree and then computing degree related to earth science at Keele University. And I've tried to combine those two things into my current role with an interest in general data visualization, digitizing interpretation tools and modeling tools. So let's go around the table, as it were. So let's go for Hannah first, please.
Hello, I'm Hannah. I'm a geoscientist and a bit of a kind of techie data nerd at BGS. I'm not a developer on this project, but I do build models, so I'm kind of using it in anger, if that makes sense.
I think it makes some sense. Thanks, Hannah. We haven't seen the models yet, though. So let's go for Jonathan. If you could just introduce yourself, please.
There we go. Hiya, I'm Jonathan. I've started at BGS about 2 years ago as an apprentice software developer, but now I'm a full-time employee. But I'm mainly focusing on the web side of things as opposed to the desktop application. Yeah.
Thanks, Jonathan. Tanya, go for it.
Hi, I'm a software developer with very many years software development experience, but I've been at BGS about 8 to 9 years, working for Ben, most of that time developing Groundhog.
And I guess by a process of elimination, Steve Thorpe.
Thanks very much, Ben. Yep, I'm Steve Thorpe. I'm a sort of 3D modeler and GIS. I don't like to use the word expert, but GIS expert. I'm part of the Groundhog testing team and also the social media team. They're actually just the same team, so we just do bits of all sorts. I'm especially keen on getting BGS data out to our stakeholders, so I'm really keen on doing that. Currently running a project called the Big Borehole Dig. Sorry, Ben, I'm just using this as a bit of a plug. The Big Borehole Dig is trying to encourage people to digitize our free borehole data. So if you love borehole data and you'd like to get involved, then either drop me a line or have a look at my LinkedIn feed or the BGS news feed.
Thanks, Steve. Shameless.
Always.
Okay, so before we get started with the live demo, just take a couple of minutes just to say very quickly what the background of Groundhog is. So it's a piece of BGS built software in-house. It started out life as an internal application for visualizing certain data sets, pulling data from our internal borehole databases and so on and so forth, and to allow people to draw cross sections and things like that. It's since evolved into a product that we are trying to push out externally. It's available in 2 versions we call Community and Professional. The Community version was the subject of the last webinar. And as I said, if you want to catch up with that, check out the YouTube channel. That gives you all the basic editing tools. So it will do maps, boreholes, cross sections. You can draw, export as images. You can pull in images and switch on the BGS geological mapping layers, so on and so forth. But then today we're talking about tools that are available within the Professional edition.
Oh dear, has the Norfolk broadband struck already?
I think you might have. I think
Oh
his
dear.
internet might have gone.
Oh no.
It's going so well.
Oh dear, it was, wasn't it? Great introduction anyway, Ben. Thanks very much.
Hello.
Hello.
So we're
Welcome
off to a
back.
good start.
Yeah, indeed. Yeah, that's just what we
That's
said.
the longest
Just gently
minute
talking to
lie.
myself. Yeah, the problem I have as the host of the meeting is that I can only see a button called end on the Zoom, which doesn't seem like a good button to press
Definitely not.
with 90 odd people on the call.
Indeed.
Okay, well, fingers crossed.
Keep going.
So I've got to say all that again because I've got no idea how much of it you heard. So Groundhog is a BGS built in-house application, and it's available externally in 2 versions. We call those Community version, which is a free-to-use version for any purpose, including commercial. That includes all your editing functions, data display, bring your boreholes in, display some maps, draw some cross sections. And you can download that from the BGS website, bgs.ac.uk/groundhog. But the tools we're going to be talking about today are the 3D modeling tools, and they're available only in the professional version of Groundhog, which is our first commercial release. The commercial version is something we're doing in collaboration with our commercial reseller, which is a company in the UK called Land Quality Management, or LQM, quite well known in the geo-environmental kind of engineering sort of sectors, which is an area we're quite interested in providing solutions for. So the tools I'm going to show you today, we're very happy to give you a free trial of those for a month. But beyond that, these are part of a commercial release. And I just want to say a little bit about that. So we're not necessarily trying to replicate or compete with some of the sort of the bigger commercial players out there, your sort of Leapfrogs, Micromines, GoCAD Skewer, Petrel, that kind of thing that are coming out of the exploration sectors. We're also aware of some of the open source platforms that are available, things like the Geo Solutions, the GenPy stuff. We're trying to pitch ourselves somewhere in the middle as a kind of tool for the everyman, if you like. So it's kind of the idea is a low cost, but a kind of relatively simple set of tools for building 3D geological layer models and doing your interpretation. So the idea is kind of accessibility, affordability, and simplicity, really. So what I'm going to do is I'm just going to go ahead and make a start on the demo. So I will share my screen and we will see how we get on. So just a quick reminder of how to get in touch with us and how to get the software. So the top link there is where to download the software. It's always the same installer, regardless whether you're having the Community Edition, which is the free-to-use one, or the professional one. If you then want a trial license or you wish to purchase an annual license, then you'll have to head over to lqm.co.uk/CSM. If you've got any questions at all about Groundhog in general, or about this sort of commercial, or about the 3D products, then just drop us an email at any time, groundhog@bgs.ac.uk. So let's switch over to Groundhog itself. I am going to stop my camera for a moment. So can I just check with Steve? Can you see my screen clearly?
Yep, all good, Ben.
Stuff. Yeah. Right, so this is the main interface of Groundhog. I'm not going to labor this too much because if you want more on that, you can just rewatch the webinar that we did on the Community Edition of Groundhog a couple of weeks ago, which gives you the general features. But down this left-hand panel, we have space for data objects. We have a library of geological codes, which the idea is you build your custom library in here with colors and ornaments and so on. And there's a help tab here. This does have a link to the YouTube channel. It also has some basic sample data and so on and so forth. And it also has a link, I believe, in the published version. I'm actually running from an internal version at the minute, but in the installed version, you should have a. The help is also available under the main menu. There's a PDF user manual. So if you get stuck, most of what I'm going to talk about is in here, or just drop us an email if you've got any questions. So the geological modeling within Groundhog, I'm going to start from a map view. So Groundhog started life as a, actually, looks like I'm already in an existing project, so I'm just going to clear that down. Clear session. So let's load up example project. So Groundhog started life as a predominantly 2D application, and still a lot of the workflow is based on sort of maps and cross-section views and things, but we will get into the 3D and the 3D visualization in a few minutes. With the 3D geological modeling for Groundhog, everything is grid based, so you first define your model extent. So let's do that first. So I zoom into an area of the map that I'm interested in, just for context. We're just on near the Norfolk coast here in the east of England. So I've got here switched on a topographic base map for Great Britain, and I've just switched on Groundhog comes preloaded and pre-configured with the BGS web map services for geology, for example. So the idea is that you just arrange your map approximately where you want the model to be, and then in the tree here, there's a models folder with a subfolder for layer models, which is where we're going to build our geological model. So if I do right click, I can just build new model. And that gives me an input for the basic information for the extent of the model. I've got a few buttons across the top where I can put a sort of rubber band around my data if I have some, or I can do extent from map. I'm just going to do that. So that will stamp in the easting, northing grid coordinates, min, max, x, y for the visible map extent. I give the model a name, just call that demo model. And then we set something called the clipping or the capping layer, which is the topography that we're going to use as the top of the model. As you can see, I've got lots of grids in here that I can use. Typically, you'd bring in something like an Esri ASCII grid for this data layer. So I have preloaded a 50-meter digital terrain model for the whole of the UK. It's the Ordnance Survey open data one, but you can obviously bring your own in. You can work from LiDAR tiles, whatever you've got. That's fine. And everything within Groundhog modeling is grid-based, so I have to set a cell size. The important thing here is that doesn't matter what you set that to begin with, because you can change that at any time, and we'll explore that as we go along. So there's a couple of little checkboxes here, which I won't go into in too much detail, but by default, it assumes you want to build a block geology model. The reason that box is there is because you can just build general models of data, so you can do an interpolation of any point data you like, really. But with this box checked, it will assume you're building some kind of stratigraphic model. And there is a setting for time as well, which obviously is more to do with maybe property data or something like water level data. We won't be going into that today. So if I click apply, I can see my demo model listed in the tree here. Nothing visual happens until I decide to add that as a layer to something. So if I go ahead and add a layer to the map, I should now see my demo model is available as an option. If I click apply, again, nothing obvious seems to have happened because it's currently taking up the full extent of that map. So if I just zoom out one step, you can see hopefully this rectangle, which is showing the outline of the map. models can be square, rectangular, or they can be a polygon shape. And the way we do that is to define a rectangular grid, and we then draw a shape on top of it and use that as a clipping polygon. We'll perhaps come into that later, but for the moment, let's just have a kind of square model to work on. So the resolution stuff, if I go into the settings, we can switch on. So these are the settings for the model itself. I can check on model grid, click apply, and you can see the grid that the model is going to build to. As I said before, the idea with the Groundhog workflow is you start at a coarse resolution because that's much quicker to build, and then you increase your resolution as you want to generate more outputs or get more refinement on the model. So let's just switch that off for a moment to avoid cluttering the screen. So I'm not going to show you every single in and out of the modeling workflow within Groundhog today, because that will probably be sort of a day-long training course. So I'm just going to breeze through some of the key tools you've got. So as a kind of caveat, the modeling tools within Groundhog are currently not fully formed, I should say. So there are some tools available. There are some things we don't have support for. We don't have support for faulting, for example, at the moment. We don't have support for sort of lens-shaped bodies, but we are working on some of those things for the next version. So I'm just going to show you the basic tools we've got in this current first version. So Groundhog treats modeling in terms of layers. And if I go back to the edit model dialog, there's a blank panel you can see on the right of this dialog, which is where the layers will appear. And I'm just going to create a layer. And what I'm going to try and do is just build a very kind of rough, almost conceptual geological model off the basis of this geological map, so that you can get a feel for how the tools work. The map we're looking at here is a series of chalk layers in northwest Norfolk. I'm going to say, for the purposes of this exercise here, we're not going to build a true exact geological model of this area, but for the purposes of the context, these are chalk layers dipping gently to the east. So we're going to use that as the basis of our conceptual model. So we have this new layer dialog here. I'm going to take the names of these units for granted, and I'll show you how I find those in a moment. If you are modeling with British geology, how you can query the layers. So I'm going to build a layer called Carstone Formation, and I'll show you where that is on the map in a second. I can choose a color for the layer just manually, or if it's in my coding scheme, which is the library panel of Groundhog, if I click automatic, it should pick that up. Looks like I may not have a color at the moment, so I'm just going to pick one manually. So I'm not going to work for this demo. I'm not going to work to the exact colors of the map. And the first thing I'm going to do with the modeling is I'm just going to work from structural inputs, so dip and azimuth. So I'm working on an individual layer here. And again, the panel on the right is waiting for inputs. So if I click add an input, because I have no data loaded into Groundhog yet, I can only do these what we call fixed inputs. So I can do fixed elevation, depth and thickness, or I can do fixed dip and azimuth. We'll come on to the data inputs in a few minutes when we try different methods of working. So I'm going to go fixed dip and azimuth for the moment. Click OK, and that brings up this little input dialog. So the idea is I'm dropping in a structural value at a particular easting, northing or XY location. I can optionally set a Z if I'm at subcrop, or just leave it as a default to pick a value from the elevation grid. So I can type values in here, but I can also just click in the map. So if I click a location in the map, hopefully you can see a little red dot appears. This is going to be the location of the input, and that gets stamped into these fields here. And I'm just going to stick in a dip value. Obviously, I've sussed this out already, and I think this is roughly right for the conceptual model. A dip of 0.5 degrees with an azimuth of 75 degrees, and that gets added as an input to the layer, and that's all we need for the moment. So let's click apply. So now you can see we have one layer within the model. So I'm just going to build that to show you what happens. So if I click apply and build, in the lower left corner of the Groundhog screen, there's a little green progress bar which tells you how far the model has progressed. In this case, because we're at quite a low resolution, it's very fast. Again, it appears that nothing's happened. The reason being because the graphics don't know yet about that layer, so we have to go and check that layer on. You can see that's now appeared as an option. And there are different ways of visualizing the layer. So we can visualize the value, which will give you a kind of shaded elevation image. We can view as coverage, which is what we're going to mostly use for this demo, which gives you a solid map of the model. And you can view thickness or isopac as well. So let's go coverage. Now we can see, if I take off the transparency, that this has built a model layer, and we're seeing the 2D expression of that layer. And hopefully, because I've put in reasonable values for that dip and azimuth, you can see it kind of matches this mid-green unit here. So I'm just going to query that. So if you're working in Britain, you can switch on the BGS layers and you can query these. You can see this layer here is my karstone formation here. So let's have a look and see what that actually means in a kind of 3D sense. So let's open up the 3D panel and add the model into 3D. So that should take a moment to load. And as you can see, it's a kind of block model, a grid-based block model. And it's gently dipping towards the east. So it's built that entire layer just from that one input. And obviously we're only working really at a conceptual level here. So we've got no data, we're just putting in values. And you can just carry on and do that for all of your layers. So obviously here I'm in quite a simple layer cake geology, but for the purposes of demo, it's a good way to show these tools. So let's say that I want to add this sort of narrow mid-green brownish band here. So let's do the same thing again. Add the layer. Let's just check what it's called first, actually. So let's query into the BGS map. So this is the Hunstanton formation. Those of you familiar with the area will know that as a kind of red band of chalk that outcrops from the Hunstanton cliffs. So let's edit this. I'm going to add that as a layer. Do I have a color for that? Possibly. I'm happy with that color. I think that's fine. And let's do another fixed dip azimuth grid input. Pick a contact on the base of that mapping there, and let's put 0.5 and 75 again into there. Click OK. By default, Groundhog will build the new layer at the bottom of the sequence. So this dialog here is your vertical stratigraphic sequence. So we know this is actually wrong in this case, so I just need to drag that to reorder to put it on top of the karstone formation. I'm going to add another one. So this pale green layer on top of the Hunstanton formation, let's just apply there. Let's just see what that is. So let's click here. This is the West Melbury chalk. So let's just copy and paste that. The names are irrelevant. It's just free text, but I'm just trying to be true to the map as far as possible. So let's just call that West Melbury formation and choose a color. Let's go for a slightly more pale green for that one. And let's do another fixed dip azimuth on there. Click a point on the base contact for that particular layer. Again, dip 0.5 and azimuth 75. So this is just a quick demo to show you basic workflow. We'll get into data inputs in a moment. So again, I need to drag that up to the top. So you can see we're beginning to define our sequence. And then I'll just click apply and build. That will take a moment to build the model. Zoom out back to the model extent. Switch the model on. Actually, let's deselect that. Then I just need to go in and switch those layers on because the graphics doesn't know about the model yet. And obviously we're working at quite a coarse resolution here, so it's kind of done a reasonable job of predicting the map. But let's just have a look in 3D. So I've possibly made that Constantin layer a little bit too thin there for the resolution in the model, but it hopefully gives you a bit of an idea. And let's put some transparency onto there. So as you can see, you can quite rapidly build up models. I could also use other types of fixed inputs. So let's say I want to put a base to the model. I can just stick in another layer at the bottom. Let's just call this model base. I'll just leave it as gray. And let's do fixed elevation this time. I'm just going to stick in a value that I know works for this region for speed, -50 OD. And I'll just leave that on the base there. Apply and build. And that should fill the map. It's gone blue for some reason, live demos. Let's just set a color on there actually. So that's gone a little haywire. Let's make it pale blue. And rebuild. So if we come back to 3D, you can see the model loading. As you add more layers, obviously the model building takes a little bit longer. Let's put a bit more vertical scale on there. So you can see, again, I've probably modeled this Constantin layer a little bit thinner than would suit the resolution of this model. So the outcropping leaves a little bit to be desired, but hopefully that gives you a first impression of the sort of speed you can do basic sort of conceptual modeling within Groundhog. If you then want to increase the resolution of your model, you can just go in and edit. You can just change the cell size to whatever you like. Obviously, within reason, there is a limit to the processing power and to the 3D graphics. The 3D graphics element of Groundhog is probably the most beta element of the software at the moment, so your mileage may vary a bit as to how that performs. So hopefully that should start loading up in a moment. So that gives you a first idea of the model building within the software in terms of how we handle things as a grid-based model with a series of stratigraphic layers. What I'm going to do now is I'm just going to, I think I might clear down the session, maybe just clear down the model, build a new model, and we're going to work from data inputs instead. So let's just going to rebuild that at a low resolution for speed again. So let's go back to 100 and rebuild. Okay, so obviously those tools for just kind of a fixed dip azimuth input are of limited use in real applications. That was just to give you a quick view of what's going on within the modeling. So let's start working to some data inputs. So I'm going to actually delete a couple of these layers out of the model. I'm just going to leave the model base there and rebuild. So at the moment now we have just a model with a flat -50 meter base. You can see the 3D is caught up. So we've just got a block volume of rock there. So we're going to start rebuilding up those layers from inputs. So I'm just going to switch the model off for a moment, and we're going to work from, we'll start with some borehole data and some mapping. So let's bring in some borehole data. Now I have a really basic example here. So Groundhog can accept CSV. This here is we just have one borehole, just for speed and ease of demonstration, that proves a few of these units. So let's import the boreholes. There's more on how to work with boreholes in the recorded webinar on the intro to Groundhog. But we can work in terms of a color file and geology. So let's browse for that file. It's a text file, but we know really it's CSV. When you bring borehole data into Groundhog, you have to go through this mapping exercise so you can tell it which field means what. So I'll map the ID, easting, northing, or X and Y. And in this case, we have a field called GL, which is the Z or ground level. And then for the geology, let's choose basically the data's in the same file. So reselect the same file. Again, map the ID. And in this case, mandatory fields are from and to, because we're dealing with geology interval data. The data looks just a little bit like this. So you can see we've got intervals. So click OK. Give the folder a name. And you can see we've got this now as a borehole stick available. So it's proving just a few of these layers, the West Melbury Chalk, Hunstanton Formation, Carlstone, and then I've just got a kind of basement just to base out the borehole there. So let's just pop that into the map, see where it is. So hopefully it's somewhere within our model area. So let's just check off that. Yeah, so switch the model on. So we now have this little borehole location here. So I'm going to rebuild those model layers just from that borehole information and see what happens. So let's add back in the Carlstone Formation. Pick a color. And then I'm going to grab, so now because we've got some data loaded, borehole data is an option as the import here. So this list slowly builds up as you add mapping, cross sections, etc. Borehole data. Click OK. Because it's detected it's a borehole, I then need to map because I might have multiple fields within that borehole data set. I need to tell Groundhog which folder and which field to use for the geology. Click OK. It will then scan that data set and ask me which formation I want to use as the pick for the base of that layer. So we're working on Carlstone here. So these values are being pulled out of the borehole data. Groundhog can ignore base contacts on boreholes because obviously they're not necessarily the true base depth. We'll just click no for the purposes of demo there. So now you can see we've got one input where we're going to use the geology intervals, the geol field, where geol equals Carlstone Formation. Again, it's put it at the base of the model, so let's drag it above there and let's build. And let's switch both layers on in the map to see what's happened. Probably nothing particularly good because we've just got one borehole there. So yeah, so it's flooded the whole area from that information because it just has one value there. So let's start adding in a bit more detail for that Carlstone layer interactively. So let's just check off the model for a moment. So I'm going to work from just a few outcrop points for now, just to show you how to do that. So I'm going to create interactively a point layer. I'm going to call that Carlstone point inputs. And then we get this new layer in the map here, which I can edit. So if I click on a layer, it becomes the edit layer or the active layer. And in the case of things like points and lines, it gives me this little tools palette here that I can use for digitizing. So let's just drop a few locations on the base. So Groundhog always works with bases. So let's just drop a few points on here. Just picking off the BGS map to see what that difference that will make to the model. Okay, so if I were to just rebuild the model now, it would have no effect because Groundhog doesn't innately know or automatically know that those points are to be used for that particular layer. So as with everything else, I need to tell it which inputs to use. So I'll go back to my model edit dialog, back to the Carstone layer settings. And here's my borehole input. So I now need to add the point input. So I now, as you can see, because I've created this new data layer, it's available as an option. Carstone points inputs. The order of these inputs is not important because it will basically treat them all as the same weighted information, whichever order you put them in. So let's rebuild that and see what happens. So hopefully you can see now that from that information, it's been able to much better resolve that layer from a few outcrop points and one borehole. Obviously, I'm not suggesting you would really use such a sparse amount of data for your 3D modeling, but for the purposes of a simple demo, it's just what we're doing. But hopefully it gives you an idea of the simplicity and the speed with which you can get some kind of conceptual model up and running. Let's put some transparency on there so you can kind of see what's going on. So we may be happy with that, or we may not. We can add more points as we wish. So let's just ramp down the. So if I just then draw some more points, it will take those into account the next time I build the model. So it doesn't always rebuild the model in the background all the time. You have to do a sort of right-click build. Then it will take that information into account. Obviously, if I start inputting, let's say I put a few points over here for no good reason, and then build the model, it will start to behave potentially erratically. So it's putting a little bit of the layer over here now. We don't want those, so let's just delete those few points. Okay, and let's rebuild. So the idea is it's a kind of interactive, iterative model building process. So before I go into other types of inputs, I just want to put in the next layer because I want to show some of the cleanup tools that are available. So let's switch the model off for a second, switch off the Carstone inputs. And I'm going to ignore this thin Hunstanton layer just for a moment and go straight to the West Melbury, which is this this sort of pale green layer in here. So let's just add a few points for that layer. Let's make a new point layer. West Melbury points input. And let's just digitize a little bit. I'm being very, very rough here. It's just for a quick demo. So please don't be too harsh on the accuracy of my digitizing. Let's just pick a few points off the base of that layer there. And let's add that to the model. So new layer. West Melbury. It's going to make it pink this time. That's fine. It's just for a demo. So I know that I've got a pic of that in the borehole as well. So I'm going to add the borehole data in. So from the geol field, West Melbury chalk. Just click no to that one. And I'm going to add those points that I just drew as well. So here's my West Melbury points input. Click OK. And let's drag it to the correct stratigraphic position within the model. And let's build that. So I'm going to switch that layer on in the map. If you remember, they don't automatically come in at the moment. And decrease the transparency. Now, what you can see here is that this sort of pink purple layer here is actually, I'm just going to put this into a slide view. So we have this tool where we can quickly compare two layers within the model, within the project, sorry. So you can see it's kind of used the outcrop information, but it's actually sort of bled out into this little sort of toe structure down here in the southwest of the model. And if we want to get rid of that, we can just use a control point. So let's go back to the West Melbury point input. I'm just going to place a point here, and then I'm going to right click that point, and there's some modeling tools depending on context, and I can just do something called cleanup. If I then rebuild the model, you can see it will trim out that little location there. So all that's doing is just pulling the model up into the air a little bit at that location. So you can see the end result here.
Have we lost Ben again?
Hopefully that doesn't mean I've frozen.
Oh, no, you've just come back, Ben.
Oh, okay.
Cool.
How much of me did you lose?
Only probably a minute.
Okay, cool.
30 seconds.
Yeah, sorry. Okay, so did you miss the model cleanup point that I placed in the?
No, you just dropped
Southwest.
out after. No, you did the model cleanup, and then you were just shown as the model.
In
to show
3D.
what had happened in 3D.
Yeah. Okay, so let's just bring that back up quickly. Okay. So the next thing I'm just going to do quickly, I'm just aware of time. I want a few minutes for Q&A at the end if possible. I'm just going to show you a cross-section input. So I can use a cross-section to constrain my model. So I can just put that anywhere across the model like this. And then I can view a cross-section panel. It's currently minimized, so let's bring that up. And I can view the model in cross-section as well as 3D. Let's put some vertical scale on there, so you can see roughly what's going on. I should just point out for those who are eagle-eyed, the model at the moment does not match the terrain. That's because of a mismatch of resolutions, because we're working at a coarse resolution. But let's say we want to pull some of these layers around a little bit. I can switch on my geology layer within the cross-section, pick a drawing code. So let's work on the carstone. And then I can just draw something into here like this. If I rebuild the model now, it will make no difference to the carstone layer. Let's just pop the legend on for that. There isn't one there. Just to remind you what the layers are. So yes, if I rebuild that, having drawn a bit of cross-section, it will make no difference because, again, the model doesn't know about that digitizing yet. So I just need to go in and add that as an input. We're working on the carstone here at the minute. So we've got boreholes and points. I'm going to add a third input, which is the cross-section. And you can see now, because I have some cross-sections or one section in my project, it's available as an option. And again, it's just going to ask me to drill down and select which digitized unit I want to use as the input. I've only got one at the moment. Obviously, in a real project, you could have many. So now I've got a third input, which is wherever there's a cross-section with a base of carstone, use that. So let's apply and build. And hopefully we should see that that pulls the model around. So this is a slice through the model here that we can see. And hopefully in 3D that will have refreshed so you can see that pulling the model around. Okay. So this is real sort of whistle-stop tour stuff. I just want to use a couple of minutes to show what you can do in terms of possibly quaternary mapping, for example. So if I just want to put, say, a little bit of superficial on top of this simple bedrock model, I can do that with some mapping. So you might bring this in from a shapefile, for example, but I'm just going to draw it interactively just for simplicity. So I'm creating a shape layer called till map. Let's just move that. And I'm just going to draw some, with the pen tool, just some arbitrary shape there and convert that to a polygon. Let's just make that a bit thicker so we can see it. This has gone green because I've got Carstone as the active layer, but let's just ignore that for the moment. So I can use that as an input to a layer. So let's just go back to the model and let's put a till deposit layer on top of the model. Let's pick a random color for that. Let's go dark blue. And then I can just use that shape as the input. So I've now got till map here as an option. And if we add a shape layer rather than a point layer, we get this very important dialog here. I can either use shapes just as guides or inputs into the point cloud, X, Y, Z, or I can use them as a hard boundary or something we call a coverage. So that's what I'm going to show here. If I set a particular shape or set of polygons as a coverage, it will use it more as a hard boundary, which is useful for things like these superficial deposits. So again, it's popped out on the bottom of the model, so let's drag it to the top. And let's just apply and build. Switch the till layer on in the map. And you can see it's filled that, and it will honor the boundary. So unless you're in coverage mode, it will run in a sort of more semi-implicit mode where it may leak out and you may need to add more control. But in the case of a coverage, it should honor that. Again, it doesn't look too great because we're running for the purposes of demo really coarse resolution here. So there's a bit of something strange going on with the graphics. But you can, of course, put a cross section through there if you want to. So let's do that. And let's just draw a little bit of till into there. Let's add the model so we can see what's going on. And let's just pick, I'm just going to use the drawing code of clay for this to represent the till. I can just pop a bit of something in there. Add that to the till layer as an input. From the cross sections, wherever we have clay, apply and build. And that will start to pull that shape around. Okay. And this is a really simple demo, but in practice, it will cope with very complex superficial mapping in theory. So I can do things like windows into the till, for example. It will automatically resolve that. So if I draw an extra little island within that and rebuild, it should resolve that automatically within the model. And it will do that to any level of detail. So I can also have little islands within holes and so on. And that should work to most levels of detail. So you can do relatively complex kind of superficial deposit maps on top of your bedrock model if you wish to. So that kind of gives you a bit of a whistle-stop tour. What I want to show just finally is what these models look like in terms of outputs. So this is my project folder here where I've got the project saved. When you build the model, it generates a subfolder called models. within that, because you can have more than one model within your project, which could be quite useful. You could have various different conceptual models side by side for comparison, for example. Gives you a folder for each one. And in here, it gives you a series of outputs, which you can drag into, say, a GIS system, for example. So it will give you your actual deposit maps, thickness, elevation maps, things like that, coverage maps with world files. But it will also give you a CSV file of all the input points that we use for the model for that particular layer. So you could take those out to another modeling system if you need something a bit more sophisticated. And it also exports an elevation and a thickness grid as well. So that's potentially quite useful as an output. One other final quick thing before I drop out to Q&A for a few minutes is all of these things can be switched on and off interactively. So if I go into edit a model, if I want to suspend a layer from the modeling, I can just uncheck it. Or if I want to suspend a particular input, so if I want to see what happens if I take my borehole data out of the model, I can do that. So I can quickly drop things in and out to see what effect they're having on the model. So you can see I've taken the borehole out here. That's had a little effect in this corner here on that sort of pink-purple West Melbury formation. I'm just going to stop sharing the screen now because that's kind of everything I wanted to show, I think. We'll drop into a bit of Q&A. There are quite a few things we haven't had time to show today, and we'll try and do those potentially at another time. Other types of inputs that you can do. So I'm just going to start my video again. So other types of inputs you can have are things like structure contours, for example. You can have thickness points. So you could say drop a point in. You could then set a thickness attribute on that, and that will be used in the modeling. Or you can draw a line and set either a thickness or a Z value on that to use it as a structure contour. So you can, for example, build maps, models straight from structure contour maps, things like that. But too much to do in the space of an hour probably as a demo. Thanks for your time. Sorry I went a few minutes over there. Had a couple of technical issues. I apologize for that. So I guess we'll drop to Q&A. I'm not sure